So this lesson is 6.2, day 2, still solving trig equations. However, these ones we're going to need to factor. And also, these angles will all be found on your unit circle, so you do not need your calculator like we did in 6.2, day 1. To start us off, look at the first two examples. It says to solve the following, given theta is greater than or equal to 0, less than 2 pi. Therefore, my answers should be in radians. So always pay attention to your domain so you know how to leave those final answers. Now take a look at example 1. 2 sine of theta plus 3 equals 4. This is something that we did on the first day. I need to get sine completely by itself. I'm going to start by subtracting that 3 over, and then go ahead and divide by 2. So we get sine of theta equals 1/2. Look on your unit circle. Where is my y-coordinate a positive 1/2? Because that will correspond to where sine of theta equals 1/2. Well, that happens at pi over 6, and again, we're in radians, and 5 pi over 6. And those are my two solutions. If we look at number 2, it's slightly different. This has actually already been factored for us. Cosecant of theta plus 2 times cosecant of theta minus square root 2 equals 0. Think about this as another algebraic equation where I'm solving for my solutions. When is this going to equal 0? We apply the zero product property. So either cosecant of theta plus 2 equals 0, or cosecant of theta minus root 2 equals 0. Now I have two equations to solve. Get cosecant by itself. So cosecant of theta equals a negative 2. And then since we're more familiar with our three main functions, sine, cosine, and tangent, I want to change my cosecant to a sine. If I change the function, I need to change to the reciprocal, negative 1/2. And remember to keep the signs the same. Reciprocals will follow those same signs. From there, back to the unit circle. Where does sine of theta equal a negative 1/2? Well, that's going to be my y-coordinate is negative. Look in quadrants 3 and 4. And again, we're in radians, 7 pi over 6 and 11 pi over 6. And those are our two solutions. But yet we had another factor, so you do have to solve this one as well. Go ahead and get cosecant once again by itself. Worry about getting the function by itself first before you go ahead and flip it. So now I'm going to say reciprocal is sine, 1 over root 2. Well, that doesn't match exactly to our circle because it's not rationalized. Multiply by root 2 over 2. And now I have where does sine equal a positive root 2 over 2. Again, look at your unit circle. This time I'm positive. You're up in quadrants 1 or 2. Y value is root 2 over 2 at pi over 4 and 3 pi over 4. Once again, all of those answers need to be in radians based on what our directions had set. Okay, go ahead and look at the next example. I'm going to go ahead and move on. What happens if there is a square on one of the trig functions? So now you're going to actually have to start by factoring. So we've got cosecant squared minus 5 cosine minus 6 equals 0. I can't get cosine by itself like we did yesterday, so now I have to go ahead and factor. My little this looks like box is going to help us in translating these to algebra. So I want you to think about this equation as not a cosine squared, but an x squared. Not a minus 5 cosine, but a minus 5x. And a minus 6 equals 0. Just go ahead and factor that. Regular x squared minus 5x minus 6 equation, that's going to break down into two binomials. It's going to have an x and an x. What multiplies to negative 6 adds to negative 5, negative 6, and a positive 1. Same idea when we're doing trig, except instead of an x, I have a cosine of theta. Think about that cosine of theta as your x variable. So I want to go ahead and factor this. Set it equal to 0. Well, it's going to break down the same way my algebraic one did, except instead of an x, I'm going to plug in a cosine. So cosine of theta minus 6, cosine of theta plus 1. Then we still want to solve, same thing, either cosine theta minus 6 equals 0, or cosine of theta plus 1 equals 0. solve each of them, find all of our solutions, get cosine by itself. Now it's not squared, so it's not a problem. Cosine of theta equals 6. Now 2 things. I told you all these answers would be on the unit circle. Well, that one's not. But another thing to notice, you could either go ahead and, like we did before, second cosine of 6. You're going to get an error because, once again, remember your sine and your cosine values. So you can never go past a positive 1 or be less than a negative 1. So this does not give me any solutions. The cosine of theta will never give us a positive 6. That does not mean this equation has no solutions. I had another factor. So I want to go ahead and solve that one. Subtractor 1. Where can cosine of theta equal a negative 1? Well, that can happen. Where's my x value, negative 1? That's going to happen at 180 degrees. In this example, we ended up with only one solution. We're not always going to have 4 or 2. It just depends on how the problem gets worked out. All right. So let's go ahead and try example 4. I'm going to move on to the next slide. Solve the following. I'm going to go back real quick. I did forget to mention, I believe you've got a blank on your notes there, that why was I leaving all of these answers in terms of degrees? Because it told me to. My bounds now changed from radians on the first 2 examples to now degrees. I'll make a note of that. Okay, so now we're on to this one, and once again, I'm still in degrees. I have 2 cosine to the 4th equals cosine squared. Once again, come over to my algebra box here. This is similar to saying 2x to the 4th equals x squared. If I wanted to solve for all of the solutions of x that will satisfy this equation, you need to start by subtracting your x to the x squared to the left. And I'm going to make a big red note. Don't divide that x squared out. We're not dividing it out because you will then lose solutions. I want to factor it out. So you still set it all equal to 0. Pull that x squared, that greatest common factor, out. What am I left with? 2x squared minus 1 equals 0. And then once again, I've got 2 factors to go ahead and set equal to 0. So coming back to the example in terms of trig, once again, I want to bring everything over to one side, set that equal to 0. Same thing, don't just get rid of that cosine squared. It's still in my equation. It's still important and gives me solutions. I just want to take it off to the side. And then I'm left with a 2 cosine squared minus 1 equals 0. Take those 2 factors, set them both equal to 0. This one gives me cosine squared theta equals 0. This one tells me 2 cosine squared theta minus 1 equals 0. From here, take the square root of both sides. Well, the square root of 0 is still just 0. So where does cosine of theta equal 0? And again, we're in degrees. My 2 solutions here is 90 degrees and 270 degrees. Don't forget to keep going. We have another factor that's going to give me even more solutions. So go ahead and get cosine squared by itself. I'm going to add that 1, divide by 2. And same thing, I need to get cosine completely by itself. So we're going to go ahead and square root. Cosine theta equals, square root of 1 is just 1, square root of 2. And whenever we take the square root, it's always plus or minus. Keep going, one more step here. Let's rationalize. Still plus or minus root 2 over 2. So now I am saying that cosine of theta can either be positive root 2 over 2 or a negative root 2 over 2. Well, if we look at our unit circle, I now have 4 values that work. That x coordinate is a positive root 2 over 2 in 2 places and a negative root 2 in another 2 places. So we do need to list all of them. We have 45 degrees, 135 degrees, 225, and 315 degrees. So yes, this problem has a total of 6 answers. Okay, moving on, we're going to skip over example 5 and just kind of start talking about the domain. What if my domain changes? What if it asks for all solutions, not just angles from one rotation, not just from 0 to 360 or 0 to 2 pi? So I want you to think about just 45 degrees. What other angles represent 45 degrees? Or in other words, coterminal angles. So if 45 degrees is an answer, I could add 360. 405 degrees would also be an answer. It would still satisfy those same coordinates. I could keep adding 360. 765 degrees would be another answer. Well, what are we doing? We're just adding 360 degrees and adding one full rotation. I could subtract as well, and I could continuously get more and more solutions. So if it asks you for all of them, I don't want you to write out every single answer. You wouldn't be able to stop because you can keep adding. So instead, we're going to say we're going to add 360, or we're going to add 2 pi, and then after we go ahead and say add 360, we're going to put this little n next to both of them to represent that I can continuously add that. N is an integer, which is any 1, 2, 3, 4, -1, -2 value. So I can add 360 once, twice, 3 times, and that's just representing that I'm adding it until we've gotten all the way up to infinity. Another way, instead of writing n as an integer, we have a notation that says n is contained in this little e, so that means in the set of integers. We write that big capital Z, and that tells me n is an integer. So let's just try one example with this all solution idea. So let's look at example 6. And it says to term all solutions in radians. You're going to start by solving this the exact same way we did the last couple problems. We still need to factor, we still need to find our solutions just from 0 to 2 pi. And again, I said 2 pi because we're in radians. So we're going to go ahead and factor this. If you need to write this out in terms of algebra, 2x squared plus 5x plus 2 equals 0. Well, how does this factor? 2x plus 1, x plus 2 equals 0. Transfer that over to trig. My x is really cosine. So I've got 2 cosine theta plus 1 times cosine theta plus 2 equals 0. Take each of these factors, set them equal to 0. I'm going to get cosine equals a -1/2, which tells me that theta equals 2 pi over 3 and 4 pi over 3. But since we wanted all solutions, those are not the only solutions. To represent that I'm going to have more than just those, I'm going to go ahead and say, let's add 2 pi, but not just once, n number of times. I can add 2 pi once, twice, 3 times. I can even subtract it because n is both positive and negative values. So you don't have to say plus or minus. You can just say plus 2 pi n. And then we've introduced this new variable into my answer here. So you do need to make a note. What was n? Well, n is just an integer. Again, n is contained in the set of what kind of number is it. That big Z means an integer. So these are my first 2 solutions, and you just leave it like that. I'm not really going to add 2 pi, and I'm not going to write them all out. Just represent that I'm going to add some more solutions there. We still had one other factor. So I have cosine of theta equals a -2. Once again, all of these should be on the circle. If you look on your circle, you do not have an x value of a -2. If you try this on your calculator, second cosine of 2, you will get an error. This is out of the domain for cosine, so I have no solution from that factor. So in this case, my only 2 answers are 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n, where n is an integer. And I will save that last example for in class tomorrow. Go ahead and stop your video, make sure you've gotten all your notes down, and come with questions tomorrow.